Okay, so record uh, and the screen. Okay, share my screen. Um, well, first of all, uh, you may try to join using the QR code, or if you prefer using the website code, you may also try to check that out. Okay, so our course, Engineering of Math. Uh, this is Engineering of Math 1. It's supposed to be having the second part, so there will be another Engineering of Math 2, but I'm still not sure whether we still have that after after this course. Okay, the first part of the Engineering of Math. Okay. But nevertheless, we are going try to finish the uh, the whole semester with some topics, okay, especially related to the differential equations and uh, some factor calculus. Okay, some part of it we have learned before if you take calculus 1 and 2. So this is just a little bit of continuation of what you have done before. So I hope you still have um, your notes, okay, your calculus notes, because I think some part of our lecture you need to turns back to your notes to review. Okay. Okay, I think I can start to introduce you for the lecture. Okay, my name, in case you are new to my class, I think most of you are already taking my class before, the Calculus 1, 2, also another course probably. So for those who are new, my name is Iman Adipurama, and basically will be your instructor. Uh, I'm graduating from material science, uh, but I have interest in math uh, and especially uh, fundamentals math and calculus. Okay, so we actually have two codes. I'm not sure why this happened because I think the problem is within the system in the and the curriculum. Um, so I need to manage two sections in Moodle. The first one is the CE, the second one is the GD part. Okay, this is for CE and GD, a different program, right? Different program, but actually we have the same course, so they still not yet solve this problem. So we have two codes. Okay, some students may try to if you have friends who wants to add the code, please make sure which code you want, the CE or GD. Okay, so if you have friends like from outside of your department and would like to join this class, uh, you need to confirm whether he or she wants to take the CE code or the GD. Okay, but both are the same course. Okay, both code here they are the same course. Okay, okay. Uh, Next is the syllabus or the textbook for our course. Uh, the first one is the primary textbook, Advanced Engineering Mathematics, by Dennis Ziel. The second book is just additional reference. Um, same title but different books, okay, different books, and I think different approach. Okay, I'm using this when I was still student, the crazy one, but I think it depends on you, uh, which one you prefer if you want to read. Uh, the second book is actually easier to follow. It has more, I think, easier wordings and not really much content. While the first one is really complete. It's really complete, but some part of the words you may find it's not really that easy. But it's actually good. Good. Okay. The other two, I believe, some of you are already familiar with. The first one is the Wolfram Alpha. The second one is the GeoGebra. That is the website. It's a cloud service for the first one is for computations. The second one is for making a graph or a graphing calculator. So let's just see what does this Wolfram Alpha can do. Is basically we can solve some equations. If you put some equations here, for example, you want uh, to integrate, for example, I can make like this, two integrations like that, or if we want, it depends on the equations. You can make your own equation. You can make it a triple integral, double integral. Let's say double integral. Um, Not sure what will be for this part here, but let's just say we have this. Okay, and don't forget to make some the equal symbols. If not, then probably the computer not really understand what the question means. And we get the results. We get the results, and they also give you the plot and also the contour. I hope you still remember what contour means. Contour means it's the two dimensions projection from the 3D plot. Okay, and also they may give you also the other results. For example, this is if you approximate using making the integration in definite integral. Okay. I think since the integration is not really complicated, they don't really show you the steps. I think it's easy to follow, right? What you need to do is just integrate one by one, integrate y, integrate the x, and then you have this. Okay. So basically, you can ask anything in this Wolfram Alpha. You can ask through the, like for example, the integration of, and then you write the function. This is also fine. 2x 4 plus 5x minus 8. Let's see if the computer understands. And I think the computer they understand what my question is. So they give this result and also they give the plots and yeah. And then they give also the approximation if you are taking the definite integral. And sometimes they have this step-by-step solution if you want to look more in the details, but you can just see the early step. The next step, however, you need to unlock and pay some money, but I'm not suggesting to pay. This is basically Wolfram Alpha is for checking whether you get the correct answer or not. Okay? So that's Wolfram Alpha. The other is the GeoGebra. It's also really helpful. Okay. For example, we start by this calculator side. we can make a graph, okay? Maybe tangent for x, and that's the graph. And maybe another one is maybe ln x minus 2, like that. And we can hide the other one so that we can focus for this ln. And basically, you can visualize the graphs to help you maybe for some observations. Okay? Uh, another thing, another thing for this GeoGebra is you can, for example, one of the topics that we are going to tackle is um, the logistic equation, or maybe before that, the slope field. Slope, I already checked this. The slope fields, we can check any resources in this website. And this is basically, you can study on your own. All this subject here is created by the volunteer who they create some activity or books inside this website, and then you can learn by yourself through all these resources. Okay. For example, if I take the maybe this one, this is the slope fields. I will explain later what slope fields mean, but basically what you can do here is you can change this equation here, and probably you can make this like this, and it's simply changing the graph. Or maybe we can have 2x minus y. It's become like that, and basically you can move out this in any way you want. Okay, so basically this is how you can find a solutions within. So the red line here with arrow, this is actually a slope. So this is a bunch of slope inside one of the graphs, and what this means is this is our equations, and basically we are plotting point by point and then making this red line. The blue line is actually if you connect some of the possible slope, it can make this blue line here. Okay. Yeah, I will tell you later in details what does it mean. Okay, and you can basically move this anywhere you want, and you can see solutions for this differential equation, but this is probably will be later. Okay, but basically what I want you to see within this GeoGebra is basically you can try to play on your own, okay, to learn, understand in which subject you are finding difficult to imagine, and you need to somehow visualize what the topic is. You can searching through the GeoGebra. Hopefully, you can find the one that you are maybe lacking in, and try to learn, okay, by your own. And that's practically what the GeoGebra is. Okay? And now it's all free. Okay? It's all free. GeoGebra is free. Until now, it's free. Okay. Okay, that's the textbook and some additional reference that might help you along the way. Okay. If you have anything to say, you can chat. Okay, you can chat me right on the chat box if you feel you have some questions. Okay. So the scoring, we have 25% for quiz. So I think either 3 or 4 times, maybe 3 quiz or 4 quiz. That depends on what we are going to progress. Okay, and we have the midterm, we have attendance, participations, final exam. Okay, so midterm and final exam both are each 30%. Why I'm making this the same percentage, because if you fail on the midterm, you still have chance in the final exam. So I consider this to at least one of them you need to get good results. Okay, if you feel like getting bad score here in the midterm, you can try to get good result in the final exam, and then quiz will help you along the way. So if you get maybe bad score in the midterm, maybe you can maximize your finals. Okay, and then you always come to the class every day, every lecture. At least you get 50 to 60%. And the other part that can help you is the participations. It can be from homework. It can be from the every week. I as usual, like I did in the previous classes. If you remember, we sometimes taking some games. I'm taking from that point. Okay, just a small percentage, but I hope it can help you. At least if you are maybe sometimes you get your final score maybe a little bit more. It could have been like you previously you get B minus, but a little bit more you can get B. So if you get good participation, I can make it to B. Okay? And usually I did that. So I'm helping you to get a better score. So that's the scoring system. Yeah, no teaching assistant in our lecture. So you need to rely on your own. Okay. So schedule, I think the class is correct, right? 517 if you check the system right now. So Tuesday and Thursday. So Thursday, we still have another class. I think it's 1 hour class. We will see each other in class, okay? For Thursday. So I think no problem for schedule, right? And then, yeah, the content. There are some adjustment. I think for this introduction of differential equation, I will do on today's class a little bit here. Just some introductions, okay? And then we move to the ODE, means the first order differential equations. Okay, first order differential equations. There are several parts here, and hopefully I can finish by this 22nd of September, and then I'm going to the second order or higher order. And then we can have the quiz 1. Quiz 1 is just the first one, the first order and the intro, the differential equations. That's the quiz 1. I'm still thinking on how we are going to do our quiz, whether we are just doing it through the online exam like usual for the quiz. I think it's okay for the first 2 quiz, or the first quiz is online. The second quiz maybe you need to come to the class. Okay, I'm still thinking about that. Yeah, that's for the quiz. And then we have the Laplace transformations. It's quite a lot, the Laplace part. So I need to have at least five classes to teach for Laplace. Basic Laplace is just normal integration with some rules in the integrations. Okay, and then we are going to learn the property, and then you can easily after the Laplace, you can basically instead doing the integration, you can just using the Laplace as operations, not okay. I will tell you later about this. And then we move to vectors, but the November 8th, I'm planning to have the midterm. So midterm will include the first order, the second and higher order, and then Laplace. So these 3 big topics will be in the midterm. Okay. This vector is just additional to fill in the weeks here, okay, because it's just 1 hour. I need at least 2 hour class for the midterm. Okay. So the midterm is 8 November. It's a little bit different from the official schedule from your school, which is around October here, right? Around October. But I'm trying to get in November 8th. Okay. But okay, if we can maybe progress really fast, okay, maybe we are. This is for the first order has four parts, right? The first order has 4 parts. If we can make 3 parts, then we can move all the schedule. Okay, we can move the schedule. And Laplace maybe I'm preparing 5. Maybe we need only 4. So I think we can move faster. Okay? Maybe the midterm can be on the 1st November. Okay? Maybe. Okay? If that happens, then we can finish the semester early. Okay? I think that is I think good, right? For you good. So you can maybe if you have another lecture, another course that maybe finish late, you can prepare the free time for another lecture, right? So you can prepare another final, another exam. Okay. And then we move on to another vectors. Vectors is just a small part, and I think not really included all, right? So just a few parts that I think need to review. Okay. And the matrix need 4 parts because it's quite a lot, especially the details. Okay, I think the fundamental parts is just this two. The other parts is the details. I will go for how to find the eigenvalue. This is the matrix part. Okay, at least the eigenvalue, and then we move to vector calculus. I will review a little bit the calculus too, okay? Especially the double integral and then the triple integral. Okay? A little bit, just a little bit, and partial derivative, a little bit, and then another quiz. This is quiz for the vectors and metrics, and then we move to vector calculus. This is continuations. Okay, the vector calculus we are going to learn the line integral, the surface integral, and so on. Okay. And we still have two classes that I'm preparing for exercise and review. Okay, but if we are maybe taking too much time here, this is a spare time for another topics. Okay, if we need to moving late, then these 2 classes in the 16 week will be spare time. Okay, our spare time here. And maybe 1 classes, maybe no agenda, probably. It's possible. It's possible. So you can have like free time. Okay. I'm still not really having anything in this 29 December because on the 27th I'm preparing a final exam on this day. So I hope this is okay. Or the final exam can be moved earlier. So between 2022 or another day here, and I can book 1 classes. Okay, if you have, if we agree on the schedule, okay, we can move this 27 December exam earlier. Okay, if you agree, or maybe push a little bit to the back. Okay, if we need to have time, if we need more time to study here. Okay. It's actually depends on our progress and your request. Okay, if you request and then your request seems makes sense, and then we can make it come true. Okay. Okay, that's a little bit of the syllabus. Okay, maybe any questions first for the syllabus or anything that you maybe have a questions on the scoring system or maybe the syllabus. Okay, you can chat write on the chat box if you have. Well, I'm trying to set up my My screen. Okay, any questions now? Okay, let me continue a little bit. A little bit. Okay, please answer my question here. Okay, I just want to know and curious uh, for everyone who taking my course, have you passed Calculus 1 and 2? The answer yes, no, or you pass one course but fail another one. You can choose the third option. Okay, 11 already passed the course. Two students fail one of the course, either calculus 1 or 2. Okay, any other students? Only 13 participants, at least half of the attendance. Okay, pass calculus. Okay, good. Okay, I hope you guys still have you guys still have the old calculus notes. Okay, 15. Okay, I think it's enough. I think it's okay, 15. Just to, I just want to know the demographic of our class. Okay, how many of you are maybe fail both, or I think not. I think you guys, I think okay. Most of you 13 students passing calculus 1 and 2. Two students maybe failing one. So uh, I hope you can catch up the content, catch up the especially materials from the calculus part. Okay. And let me continue a little bit. This is the last slide for the introduction. Well, I'm not sure because several students taking the course, adding the authorization code. I'm not sure what's your expectation from my course. This is not the first time. I'm opening last time in the summer course, the engineering of math. So this is the second time I'm teaching the engineering of math. So hopefully you guys can take benefits from my class, and I hope you enjoy the class. Okay. Okay, make the final exam earlier. Good. I think that's good expectations. Okay, so that's mean. Yeah, I can do that. I can do that. So I think I can make some parts faster. Okay, because I think some small parts can be skipped. Okay, can be skipped. So not all section in the textbook. Practice question for quiz midterm. Okay, okay, yeah. I will make sure that before the final exam or before the midterm, we will have some small review and practice. Okay? Since we don't have any teaching assistant, so I need to make some practice with you. Okay? Okay, anything else that you want to maybe having any requests or maybe expectation from the course? Uh, I think you already know how I teach from the calculus 1 and 2, right? Learning calculus as a fundamental for other courses. Okay. Yeah, vector calculus is a little bit tricky. Um, the more you learn the math, the advanced math, like in the calculus, calculus 1 easy to follow, calculus 2 so the engineering of math, the vector calculus part, um, it seems so um, so so difficult to follow because um, you are not really see the visualization. So it's difficult to describe, and it's kind of more like it's becoming more abstract than the first two calculus. Okay, like the calculus one, it's just two dimensions, right? Calculus one, two dimensions. You can imagine the limit, the tangent, right? The slope. Okay, it's easy to draw also. The calculus two, you get the idea of the double integral and the multiple integrals in some sense, which the more you have, it's difficult to imagine how um, the visuals works. Okay, okay, get A plus, good, good. Kind of forgot a lot of the calculus two material. Yeah, some key parts, some key or important points on the calculus two, I will review for you, but not all. So I hope when I give you the key part, you can you can try to dig on your own. Okay, what kind of uh, or what's the behind the key part, and I hope it can help you to remember. Okay, easier task question. Okay, it can be done easier, but the problem is, it's not that I want to make an easy question for you. Okay, I know that some students they have trouble, uh, that they need to pass the course, blah blah blah. But the purpose of academic, like in the university, is to make some set of standard, some quality, right? So if you don't cut that uh, quality, then that will be difficult, right? It is difficult, and it's kind of the I'm trying to respect all the students, and my point is uh, what I'm going to do to respect my student is giving them question that has some quality in it. Okay, that is the objective. Okay, if I'm giving the easy questions, it means that I'm being disrespectful to you. Okay, because I'm respected my students. I try to give quality in the question. Quality means it doesn't mean that it is difficult, but it is comprehend the content in the lecture, and then the objectives is to see whether you are able to solve or able to answer or not. Okay, well, it's kind of old fashioned, but I'm trying to look on more because every student, I believe, you have different ability, different background. Okay, if you are, maybe you have background, let's say we counted the numbers, maybe you have plus 10 before, plus 10, but some students just plus 7 because it's from different background. Like for example, the international students, maybe they are having, maybe some of them 10, maybe some of them 7, 8, 6, but when they enter my class, I'm trying to see how much they improve. Okay, I will see that from participations, how they act in class. That's also a point that can be really helpful and give me insight uh, what the students really is and how they understand my lectures. Okay, so I think at the end of the day, uh, the score is just the score. Okay, it doesn't define you entirely. Okay, it's just the score. Like A plus, maybe you good, but maybe A plus is just on the paper. It doesn't mean that A plus is bad student. No, but what I mean is sometimes understand the course, understand the lecture is different from the getting a good score. Sometimes it's different. Maybe you have maybe just B, or B minus, but at the end of the day, you get the core concept. I think it's good. I think it's good. Your score is just for impression. I think just the first impression. People will look more into after the score. Okay? Like from they talk with you, or maybe when you have some performance, you have some skill set, and then maybe most company will see that as your value. Okay, because score is just the first impression. After that, it doesn't really meaningful. It doesn't really meaningful. Okay, so at least getting quite okay score is, I think, enough. I think enough. But I do respect if you are pursue a really good score. I think that's also good motivation. Yeah, notes I will upload. Every chapter ends, I will try to upload in the Moodle. So every maybe chapter one finish and I upload the Moodle. Chapter two finish, going to the Moodle, I will upload that as well. But the important thing is every lecture I will try to record. Okay, I will record all my lectures. So, like for example, today's lecture is recorded, right? And you can review later when I'm uploading the videos. And please remember, if I forgot to record, please let me know. Okay, sometimes I forgot to click the record button. Okay. 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 Anything to write? I think it's good. It's good. Really good here. So this will be the end of the slides, and I will move to. So the last 1 hour 1 hour will be um, introduction to chapter one, okay, the differential equations. So if you don't have any other questions, so I will stop the screen sharing and we will have a little bit break, okay? Maybe 5 minutes break. So you can, if you want to go to the bathroom, you can go, okay? So stop sharing. So we will have a 5 minute break, okay? And if you want to write some question in the chat box, you still can write and I will read your questions if you have one, or maybe comments, you can write also in the chat box, okay? Okay, let me share my screen, my notes. Okay, let's try. Okay, I hope you can see my notes. Okay, so for this semester, I'm using the black uh, background, okay, to see whether this is easier to follow rather than white. Okay, okay, now let me move this to here. Okay. So first is we are going to to discuss the first is the differential equations, or the whole chapter is this ordinary differential equation. Okay, let's focus on the differential and an equation. So differentials, okay, as you remember, we learned this word when we discuss calculus, and perhaps you already know before. Probably in your high school you learned a little bit of calculus, and then the word differential also comes out. That's the same word. That it means that uh, it's related to something that can be derived, okay? Like derivatives, or in our sense, usually if we have our functions, then the differentials of this is usually we can write dy over the x like this. Okay. But we can also rewrite this dy over dx with the terms that is f prime x, or we can just say that this is y prime. Yeah. Okay. If we have a functions, for example, functions y equal e with power of 0.1 x squared, for example. If you want to find its derivative, you can start just derive this as usual, like in the first calculus, and then we can write 0.2. So we can have the chain rule here, okay, and then we start to write 0.2x, and then e, and then write the same thing all over again because of the exponential, right? But if we are thinking because of the e, if we differentiate e many times, it still retains the same original e at the equation, correct? Right? So what can we do here is actually we can see that this y equal e is, we can also look at here, right? So by the end of the day, we can write the whole equations as 0.2 x y. Okay. So what differential equation here, or really are, is actually, usually we treat y as a function of x, right? And sometimes we find maybe finding the x, finding the result of differentiations, blah blah blah, right? Or maybe finding the roots if we have a function, if you want to draw and find the roots, right? But basically, it's we find, or we treat x, right, as our variable. But now in differential equations as a whole, we are going to treat y as our center. Okay, so uh, we are going to have uh, a typical questions. Okay, so the basic problem. Let me write the problem. The problem in most of the cases in differential equation is how we solve an equation or the DE. Let me write DE. If I write DE means differential equations, how we solve DE, okay, for the unknown function. Let me write this y equal, let's say, this psi. Okay, but this is actually just a symbol to differentiate with the f that I write, but it's actually a function. Okay, so it's just my way, my the symbol, just the symbols. Okay. So we call this is example of differential equation. So what we are going to find is how to solve this. Okay, how to solve this. So by solving means that we are going to find what kind of y or what kind of functions this is. Well, sometimes, because we have also learned in calculus that we can derive and integrate, some of the problems can be integrated. That's, I think, easy enough. But some of it, probably not, and maybe makes things confusing. Okay? So let me just give you the definitions. I have prepared for you. Maybe let me check. I think this. Oh no, this is. Oh no. Oh, I haven't write. Let me just write. So DE, okay, as in the definition, it's equation contain derivatives of one or more dependent variables. Okay, with respect to other variables, of course. One with respect to one or more independent variables. Okay, so that's the DE. Okay, and then we classify this differential equation. Okay, we classify based on what kind of derivatives that we can do. Okay, the first is, of course, it's just the regular derivative that we've done. Okay, we're simply taking the y as a function of x. The other derivative is when we can do some partials. We can do some partial derivative, which means that we might have two variables that are independent. Okay, and we do using the Leibniz notations, we do the partials. Okay? But for that partial, it will be not our topics for the whole semester. That will be for another lecture, okay, for a partial differential equation. So we have, let me just write a classification. First is the ordinary DE. The second is partial DE. Okay. The difference is the the independent variable. Okay, let me give you. I'm just copying from the textbook. Maybe let me make this a little bit smaller. I think too large. Let me resize this and also resize this so you can have a good view. Okay, and then resize this a little bit here. Okay, so I can put the okay, this is okay, and this part. Okay, now if you look on this, the first part here, this is the ODE, this is the PDE. Okay, how do we know? Okay, how do we know? First thing, I think the left part here is not a problem. It's just this is dy over dx, our to just to show us that it is a differential. Okay? And we have variables. We have the dependent variables y is dependent variables, and we have the x, which is the independent variable. So this is just an ordinary differential equation. And then the second part here is also the same, but we have second derivative that, yeah, it can be, and we can have the second order, right? We can have the second derivatives as well. We still say that this is the ordinary differential equations, okay? So still ODE. And then the third part here, we can have more than one dependent variable. For example, our independent variable in this case here is our dt, okay? Our dt. So we can have the x over dt plus dy over dt is equal to 3x plus 2y, okay? So this is also, we say, still ordinary, okay? Still ordinary. And we will focus this semester on this ordinary, okay? But I just want to show you what's the difference between the ordinary and the partial one. The partial one, we have this, okay, two independent, right? And then we have this, two independent also, x and t, and then this and this. We have also two independent. Okay, so that means this is partial differential equation. Okay, I hope clear from this differences. Okay, if you need to write, you can write, or if you feel you need to take the screenshot, take the screenshot. Okay, now another important thing, aside from this classification, which one is ordinary and which one is the partial, is to classify by the order. Okay, if you see from the first one here, okay, this is just the first derivative, right? The most derived derivative is just the first derivative, but the second part, let me maybe different. Let me use different color. But the second part is having the second order. So it's become the second order. Okay, so this is the first order. This is becomes the second order. Okay. Now to make things more interesting, let me just give you another example here. I'm just copying from the textbook. So if you have the textbook, you can check. It's on the early chapters. I will move to the next page. Okay. I think this, yeah. Okay. The interesting here is you need to distinguish, okay, which one is the order, which one is just a regular exponent, okay, or regular power, okay, regular power. If you see like this one, we are going to see that this means that it's you need to derive second times, right? It's second derivatives, and or we can say that this is the second order. Okay, so the order means uh, how many the functions being derived. You can say something like that. Okay? But if you see this part here, dy over dx, and then power with 3, that is not the order. Okay. So we say that because the highest order is 2 for the left part here, this is we call second order. Okay. The right one, the highest order is 4. Okay. So we call this fourth order. Okay. The second order and the more than 2, maybe 3, 4, and high, or we can say higher order, that will be the next chapter. Okay, for our discussion. Now, since I'm writing using the forms of we call this Leibniz notations. This D, if you remember, this is the Leibniz notations. Another way to write for the differential equations, you can use using the prime notation. For example, you can write y prime, y second prime, y third prime. This means that this is dy over dx. This is the 3y dx cubed. Okay, just different notations. Well, you can use both. That's still okay. Sometimes I think some classical books they write using the dots like s, or maybe the dot like that. It is sometimes also the derivative, the differential as well. It's the first dot means first derivative, the double dot means the second derivative. But I don't think it's quite often. But usually most textbook using the prime or DDX, right? The Leibniz notation. Okay, the first order usually. Okay, the first order differential equations. Usually we can write in more official forms, or we say this is the differential forms. Okay. This is m xy dx plus some n xy dy equals 0. Which means that we are going to take the first order. For example, the first order maybe from here, 0.2 xy. Then what we are going to do is we are going to solve this. Yeah, and then equal to 0. It's called this differential form. And we can also write the general form for this dE. Sorry. So we can express, if we have like more order, like nth order, n order of differential equations in one dependent variable. Let's say it's y, our dependent variable. We can express in f and then x, y, y prime, y double prime, dot, 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 until the n order, then equal to 0. So f is real value of n plus 2 variables. Which is the x, y, y double prime, dot, dot, dot. Oh, sorry. But I think this general form is not really practical because it's not really represents the DE in explicit forms. So usually we try to make into more more similar to what the differential equations looks like, which means that we need to introduce the Leibniz notations within this form, which means we are going to maybe let me make this a little bit higher, a little bit higher. Okay. So we need to assume, okay, assume it is possible to solve the ODE in this form, the general form. For the highest n order in the terms of remaining n plus 1 variables. It's a little bit wordy, but let me just explain this. So what this means is we can make it this part here in more of and then making one terms reduce one term. Okay, reduce one term. So f, and then write the same thing, x, y, y prime. And instead of y with n order, we can make this y n minus 1. And I think in some sense, this form is much more intuitive in our differential equations applications because it's already showing you the Leibniz notations. Okay, I hope you understand what I mean here. It is just show you that how we can write the differential equations officially. Okay. And that's why we can use officially if we write depends on n. Okay, if n is 1, if n is 2, and so forth and so on, then we can write down this becomes just an ordinary f x y. Okay, or if we take n is equal to, then we can write this is f x y and y prime. So okay, here's the thing. For differential equations, we are not looking like from previous lecture in calculus. we usually focus on x, right? Y is just saying that y is the function of x. Usually we say that, right? Now, for differential equation, we are going to include y as our object here. So we are going to look x, y, and if they have another differential, we need to include that as well, y prime, y double prime, and etc. So you do so basically you will be given differential equation and you need to solve and finding the possible solution for it. Okay. So this is the one that probably will be given to you. Oh, this is differential equation. But the way you see this differential equation is, oh, you need to think what kind of solution it has. Can you draw? Can you visualize the solutions? Okay. Then there will be several methods to look for this problem, to look for the solution of this problem. Okay. And there will be some application as well. But I'm still not sure whether we are going to discuss in detail for the applications. Like in some physics applications, there will be some modelings, like for example the kinematics, like the spring, the mass, the spring load. It can be modeled through differential equation as well, and then we can see some applications for that. Okay. 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 Let me give you some my personal notes. Okay. But maybe let me continue a little bit. Okay. If you want to like to stop for a while, and then I'm changing the page, let me know. Okay, you can write in the chat box. Just maybe write. Wait, I need to. Uh, oh, Eric, are you asking? I just see your question. Are you using the Crazy textbook? That's just for reference. I'm mostly using the Dennis Steele for the content. Yeah, Dennis Steele. Crazy, maybe I'm taking some parts. Okay, like just maybe questions. Okay. But if you have the Crazy and you feel that it's the words is more connected to you, I think that will be better. Because sometimes I feel that the Crazy is actually more, I think, reasonable. But for the content itself, I think Dennis is more like complete one. Okay. Dennis Hill. Right. Okay, now the next part will be the linearity. Okay, this is also important in differential equations. We need to classify. So aside classify what kind of DE, okay, and then the other thing is, so first is it ordinary or partial? Second thing is it can you distinguish by the order, like first order, second order, third order? You need to distinguish that as well for the equation. The third part is classifications by linearity. Is it linear or non-linear? Okay. Okay. So the ODE, if we look again the normal forms, this one here, I think I will copy this just to cut the time. Let me copy. Okay. So the nth, sorry, the nth, uh, the n order of the this ODE is going to be linear. Okay, it's going to be linear. Let me write linear with blue. It's going to be linear. Okay, if okay the variable y is linear, which means this variable y here, all variable is linear. So the ODE will be linear when, so the ODE is linear when we can write when, let's say, we have some constant plus, okay, we just break down all this stuff, n minus 1 and plus, and then a1 x y prime plus a0 x y. I think I need to move this a little bit down here. And minus g of x is equal to 0, or you could write down, let me check if I have a better writing here. Oh, I already have, okay, or we can write here. And if we have the first order and the second order, we can also write its linearity. Let me check if okay, I have another one. Okay, this is for when n is equal 1, or we say this is the first, or maybe linear first order, linear first order. And this part is when n is equal to, or we can say the linear second order. Okay. So from this approach and the definition of linear, you remember that we are going to look the linearity through the dependent variable. Okay? In our case here, we are going to look on the variable 1. Okay? So all the dependent variables y and its derivatives y prime, y double prime, blah blah blah, they are all in the first degree. Okay, so they are in first degree. Okay, so the power is just 1, and that's linear, right? And the coefficient, in our case here, the a, like from a0, a1 up until some an, okay, of the variable y, they depend on independent variable x. Okay, now from this linear definitions or linear structures that we have, then we can also make uh, some definition for the non-linear. So practically nonlinear is if this is not the first degree. So it's intuitively it's the reverse of the linear definition. Okay? So we can just write that the nonlinear okay or nonlinear ODE okay nonlinear ODE is equation. Let me just write that is nonlinear. That is not linear. So, which means, okay, we can see from the order, first the order, okay. For example, if coefficients of the dependent variable y contains it contains another dependent variable y or its derivatives or if the powers of y prime appears, which means it's not linear. Okay, maybe it's a square, cube. Okay, for example, if you see so it's y prime, but it's having squared like this, or maybe cube, then it's not linear. Okay. And aside from the coefficient, okay, how the coefficient works, if you see any nonlinear functions, okay, so nonlinear functions of y or dependent variables, or its derivative, will make ODE nonlinear. For example, if you see any trigonometric, for example, like sine y, then it makes not linear, right? Because it has a sinusoidal, it has a curve, right? So it's making the subjects a nonlinear also. I hope it's clear. Okay, let me just give you the what kind of example that makes uh, the ordinary differential equations becomes nonlinear. Okay. Okay. So far, is the lecture can be followed, or do you have any questions? Or is my speed for these introductions okay, or too fast or too slow? Is it too fast or slow or okay? Okay, what do you think? Okay, maybe other students, do you think it's okay, or maybe too fast, too slow, or maybe uh, not really understand the English part, maybe some words? Do you have any problem with that? It's okay for me too. Okay, Rion, thank you. Okay, let me know, okay, if you feel um, maybe you need me to slow down. I think that's also okay. Okay. Okay, let me continue. Okay, I hope uh, the words clear. Although I think it's a little bit confusing, the words, okay, the sentence. But let me just show you how we apply this in the equation itself. Okay. Okay, let me write y double prime minus 2y prime plus y equals 0, and then the other part y minus x dx plus 4x dy equals 0. We are not doing anything. We just try to classify. And our job today is to just to classify. And the other part is x squared d3y dx cubed plus 3x dy dx minus 5y equal to e equal to 2x. E with power of 2x. Now, if we just look at this tree and we need to classify the whether it's linear or nonlinear or what kind of order. I believe the first one is linear, right? It's the sorry, it's the second order, right? Second order. Okay, the second part. This will be. We can rewrite this and maybe trying to make this into here, and we see that we are having just the first order, and it seems that nothing wrong with this. So this is also linear and first order, right? And also the third part, nothing wrong with this one. I think everything is clear, not really having any trouble uh, for finding any nonlinear. So it's also not, linear, third order. So not problem here. But if we see, for example, our 2 minus y and then y prime plus 3y equal e to the x. These terms here, and we have another y here. Because the coefficient depends on dependent variable y. Then the conclusion here is making this nonlinear. Okay. And if we have as I told you, we have like sine y like this. This makes this is we call it this is nonlinear functions, right? So it's making nonlinear. Okay. let's make a little bit summary. Okay, what we are we have done and what will be um, after we classify all this thing. So the next thing we will do is we are going to define what solution that we are going to find, what solutions, and then from that solutions, what is the requirement to get into that solution. Okay. So first, let me just make some summary, but maybe in the next page. So if you want to take notes or take a screenshot, you can do now. Okay, let me sum up, okay, from the beginning. Okay, I think I haven't um, discussed this, so let me just show you the idea on the differential equation. So differential equations. So why we need that? First is because the differentials comes up from the calculus part, right? That is, if we think about calculus, is everything that has changed, right? And in our lecture, we are going to see more of its applications. Okay, so we are going to have some modeling. So this is what the differential equation used for. So modeling the rate of change. I think I already mentioned a little bit on uh, the kinematics, etc. If you can model like populations, you can model with the exponential, right? And we are going to relate derivative, okay, in an equation. That's precisely the differential equation that we have discussed at the beginning, right? So derivative will represent changes. And I think, as I mentioned before, we are not necessary. It's really bad. Let me erase it. Focus on numbers as solutions, but on equations as solutions. As I mentioned, that we have the differential equations. What we are going to find is the function itself. Okay, the function itself for that differential equation. For example, if you have like y double prime plus y prime minus 5y equal, for example, e to the x. Okay. What's the solutions? The solution means you need to write what kind of functions that when you have this and you try to derive becomes y prime y double prime, you can tailor the whole thing here and making into this equation at the first place. If that's true, then your solution is correct. Okay. So basically that is what we are going to do in the next sections. Okay. And the solution itself, okay, the solution itself usually will be more than one. Okay. Or we say we will have a family of solutions that satisfy satisfies the differential equation. Okay. And the other thing is usually we are given some conditions. Okay. We say it's called the initial conditions. So we can restrict to one particular solution. This is later we call this initial condition or initial value conditions, okay? Or IVP. This is IVP problem. IVP. Okay, and based on the order, because we already classify the order, first order, second order, and so on, the highest derivatives in our differential equations, the nth order dE will have n parameter family of solutions. So as order increase, the arbitrary constants also increase. Okay. What this is about, we will go later, and we will go in details later. And basically what we have in ODE, the ordinary one, this is all based on only independent variable x. Only one independent variable x. Let me write one independent variable x. Okay. On one independent variable x. If you have more than one, like 2, it's going to be the PDE, right? The partial differential equation. Okay. This is just to sum up what we have done and what we will be discussing. Okay. So the next thing that we're going to discuss is actually the solution. Okay. What is the solution? Okay. I'm writing here. Usually the solutions is the more than one that satisfy the differential equation. Okay. It can be done. Okay. And then usually if you have some initial conditions, we can restrict the solutions only for one particular solution, or maybe two particular solutions. That's also can be done. Okay. So let me move to the next page. Okay. This is just I think a little bit last part for today's class. Okay. So the solutions and the interval of definitions. Okay. Okay, let me go through. Oh, sorry. I think I need to make black. Okay, let me go through this. The solution of ODE. As I mentioned in my writing here, okay, the nth order will define the n parameter of the family of solutions. Okay, so what this means is First, the function need to be defined on some interval. They possess at least n derivatives. They are continuous, of course, which, when they are substituted into the ODE, they will reduce the ODE into the identity, which is the solution itself. Okay? Or we can say that when it's substituted, it's satisfied. Okay? So this, in other words, okay, if you think this is too long, solution satisfy DE. Okay. So if we have that the general forms that we have x, and then if we take the y as a function, like if we have take this y as a psi, the functions in this form, then we can write this as a psi of x, psi prime of x, and then psi in some nth derivatives of x as well. It's equals 0 on or for all x in some interval. So we say that this function satisfy the DE on some interval. So assume the solution, or maybe let me write it's going to be down here. Assume the solutions or the psi is real value. Real value functions. If we turn back to our equation in the beginning, we see that our y equal e with power of 0.1 x squared. This is a solution for its dE, dy over dx. Well, this is true because we are trying from the solutions and then writing the dE itself. So we know that if we want to find the solution of this dE, then the first equation here is the solution, right? So this is the solution for dE on interval for all real numbers, right? On this interval for all x. Well, we can also write in terms of yx like this. This is just to distinguish between the psi and y, but actually it's can write the same thing. Now, because we talk about the interval here, now we need to define first, okay, what is this interval mean? So we are not be able to think on the solution if we are not thinking about the interval. Okay, so we need to define in which interval that this solutions can be, or it's defined. Okay? So we are going to have some we call the interval of definition. Or some say it's domain of solution, also okay. Or interval of validity, it's also okay. It can be open interval, it can be closed interval, it can be both, it can be infinite interval, and then so on. Okay, to give you a little bit more sense, let me give you an example. Okay, verify the function is a solution of the given DE on interval, yes, for all real numbers, right? So the DE is, for example, this is the DE, and our job is we already have the answer, but we are going to check, to verify whether it's correct on this interval or no. Okay, I think it's easy. We are going to look on the problem here. So we can start from here and try to differentiate and checking whether it's correct or no. So dy over dx from here, we're going to have 4 over 16 x3 or x cubed over 4. And then we could also check from the left side, and then we are going to substitute, and then this will be x squared over 4. So this is x cubed over 4. So yeah, we can try different way if we want. Okay, and then to verify, we can say that from here, let me move here, that y with power of half is actually x squared or maybe let me write here, y with power of half. I think better is to look from here, is x squared over 4, right? So we can say also from this definition that by definition, this is a non-negative square root of this. Okay. So from this, we see that whatever path you choose, you end up with the same result. So the equation is the same for every real number x. Okay. Okay, one more verification, and then we are done for today's class. Okay. Just want to show you the difference. So if we have y double prime, okay, and then verify these equations. Okay. So we need to verify this as a solution to the same questions, and should be on same interval as well. Now we can check. Let me write again, and let me make the derivatives. Okay, we are going to have this plus the using the product rule, and then derive one more, and again this part is going to have another same thing, and then e to the x will be happening too, so 2ex, right? Okay. So we are going to move on, substitute to here. So x, let me make it with the bracket, minus 2, and then plus, and then it's equal 0. And then it's verified, and it's one of the solution. Okay. So as a note, each differential equation are so this and the last one here. So each differential equation, they are possess the constant solution that is y equals 0, which also defined on interval. Okay. And this kind of solutions, we call this as a trivial solutions. Okay. So every time you get some perhaps solutions that has the 0 on the some interval, it is called the trivial solution. I think I will be stopping until here in the verification. We will be going forward to the initial condition and so on, and how to see there is also some explicit solutions, implicit solutions. What's the difference? We are going to discuss that in the Thursday class. Okay. So if you don't have any questions, then that is for today's class. So see you on Thursday. We are going to meet up on the classroom, hopefully. 517. Okay, 517. And Thursday will be the, I think, 5:30, right? 5:30 class. Okay, any questions? If you don't have any questions, then that's it for today's class. Okay. So thank you all for your attendance. No attendance for the first class. However, the second class and forward, we will have some attendance. Okay. Okay, I will stop the recording.